All right, today we're going to be going over the Module 7 test review. And here is our first question. Which expression is equivalent to 17/3/8? So first thing we're going to do is we're going to write down our formula. Make sure you have your laws of exponents handy because you will need to know those. So this first one is going to look something like this. So remember, your base number becomes your radicand, your denominator becomes your index, and then your numerator becomes the power 2 on the inside. So pretty simple. It's probably the first thing you want to write down. All right, and now let's just convert it. 17 is inside the root, and then in this case our denominator is 8, so that's going to be the index, and this is going to be 17 to the third power, and that would be d. Easy. All right, let's keep going. Number 2, it says evaluate the expression. So same thing, we're going to use the same formula as before, and we're just going to put everything where it goes. So 9 is the base, it's going to go inside the radical. The denominator is 4, so that's going to go on the root, and then squared. And then you can simplify this. You can do 9 to the second power, which is 81, and it's to the fourth root. So we're just looking for what number 4 times gets us to 81. So one way to do it is just go one by one. 1 times 1 times 1 times 1. 1 4 times equals 1. Let's go to 2. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2, here, let me show you. 8, and then 8 times 2 is 16. So 16 is not the same as 81, so it's not 2. Let's move on to 3. 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So that means the number 3 4 times is going to be 81. So that means the fourth root of 81 is 3. You could have also known that this can be simplified into 1/2. So you could have done simply the square root of 9 to the first power, which is just 9. Square root of 9 is 3. So either way would have worked. Right, let's move on to number 3. All right, so for 3, you're looking to select all the expressions, keyword being all the expressions that are equivalent to 64 x to the third y to the 6. So again, you need your laws of exponents. So when we have 2 terms multiplying, because when they're right next to each other, they're multiplying, you're adding exponents. So start with your whole number. 9 times 9 is 81. Now, 81 is not 64, so I'm not even going to keep going with this one. I know that is not the answer. Let's go to the second one. 8 times 2. Well, 8 times 2 is 16. Again, not 64, so I'm going to keep going. All right, 8 times 8 is 64. So I did my 8 times 8. Now let's go to my x's. X's, well, I don't have any x's here, so it's just going to be x to the third. Y's, I don't have any y's on the other side, so it's going to be y to the 6th. And look at that, it matches. So C is our first answer. Now here we have a power to a power, so that means this power has got to be shared with everything on the inside. Now when you have exponents here, which are to the first power, it's simply multiplying. So first I'm going to do 4 to the second power, which is 4 times 4, which is 16. Then I'm going to do 1 times 2, which is 2, so x to the second, y to the first times 2, which is y to the second. All right, and that's our new piece. And then we're going to keep 4y to the fourth the same. And now we're multiplying the 2 terms, so we're going to be adding the exponent. So 16 times 4 is 64, so that's a good sign. X squared, there's no x squares here, so the x squared stays. Y to the second plus y to the fourth, because when we multiply our terms, our exponents add together, and that would be y to the 6th. And oh, that is still wrong, because this should be a 3, so just be careful, right? And then we've got one more. So in this case, we also have another power to power, so I'm going to start by sharing that too with everything in. That's 2 to the second power, which is 4. Again, any term that doesn't have an exponent means it's to the first power. So we'd be doing x squared, y squared. And that's our first piece. Now, because this one's exactly the same, I can just rewrite it on the bottom since I already technically solved for it. And 2x. So now let's look here. Now we multiply all of these together. So let's go one by one. 4 times 4 is 16 times 2 is 32. Well, I'm not really looking for a 32, so that is not going to work either. Got one more. All right, here we don't have any powers to a power, so we are just going to multiply all the way down. 2 times 8 is 16. 16 times 4 is 64, so we're good there. I've got 1x here, 2, 3 x's in total, so it's going to be x to the third. Then we've got 3, 6 y's, and that is the other answer I'm looking for. Pretty simple. So in this case, our answers are C and F. Perfect. Let's keep going. All right, here we are simplifying a fraction. So again, make sure you have your laws of exponents. You need those. In this case, we're using our quotient rule, and we also have a negative here, so that means we are using the negative exponent rule. So let's start with these whole numbers. 4 divided by 24, pretty easy. 4 goes into 24. Well, let's think of what number goes into 4 and 24. Well, 4 goes into both. 4 goes into 4 once. 4 goes into 4 once, and 4 goes into 24 6 times. So that's simplified. Let's get that out of the way. All right, now let's look at our x's. X to the negative third power. Well, remember when we're dividing, it's like we are subtracting. So this is as if you were doing -3 minus 2, which is x to the negative fifth. That means this negative means it's going to go on the bottom. So this would be x to the fifth. You could also simply just remember that if it's negative, it goes to the flip side. So that means if it's negative, it has to go to the bottom. And you have 3 x's here plus 2 more, you get x to the fifth. So that's one way of thinking. Then we've got our y's. So again, you could either subtract them. Y to the fifth minus 3 equals y to the second. Positive, so it goes on top, y to the second. Or if you're more of a visual person, you have 5 y's on top. 1, 2, 3, 4, 5, and 3 on the bottom. Cancel these out, you're left with 2 on the top. So one way or the other works. And that's our final answer. Now you could also remember that 1 times anything is itself. So if you see an answer choice, if your answer were multiple choice and you didn't see that 1 there, that's okay because it's implied that there's a 1 there. So either way works. And that is our final answer. Looking good. All right, let's move on to number 5. So here we have our exponent rule. This is going to be power to a power. That just means that power has to be shared with everything on the inside. And remember, when you have exponents raised to another power, you're multiplying instead of adding. So let's start with the 3's first. So 3 to the third power is the same as 3 times 3 times 3. So start with 3 times 3, which is 9. 9 times 3 is 27. So our first number is going to be 27. Then let's move on to the x's. So we have x to the fourth times 3, which is x to the 12th. Easy, x to the 12th. And then finally, we have y to the 8th times 3. It's going to be y to the 24th, and that's your y value. And that's it. Just remember, when you have a power to a power, share that power with everything. Exponents multiply. So that means this 4 would multiply this 3, this 8 would multiply this 3, and this 3 would just get a power to the third. Okay, let's move on to number 6. So it looks like we have another division. So again, it's important to remember your laws of exponents. So Start with the whole numbers. 4 divided by 5. Well, 4 divided by 5, we can't really simplify. There's no number that goes to 4 and 5 besides 1, and 1 just keeps them the same. So it's going to stay as 4 over 5. Okay, that's done. Now let's go to our x's. Again, when you have division, you can subtract the 2. So we can do x to the second minus 4, which gives us x to the negative 2. Because it's negative, it goes in the bottom, so it's x to the second. If you're a visual person, you can sketch them out. You've got 2 x's on top, 4 on the bottom, 1, 2, 3, 4. X's are gone. That means you're left with 2 on the bottom. So x's are done. Now let's go to our y's. Again, y to the fourth minus 2. You could just subtract, which gets us y to the second, positive, so it goes on top. Or if you're a visual person, you've got 1, 2, 3, 4 on the top, 1, 2 on the bottom, cancel out, you're left with 2 on the top. And then finally, we have our z to the 0 power. Now, anything to the 0 power equals 1. So it'd just be having a 1 here. Now remember, anything times 1 is itself, so that 1 really doesn't make a difference, so I can just get rid of it altogether. And that's going to be our final answer. All right, let's go to number 7. Find the difference. So if we remember, in order to subtract or add, they have to have 2 things. They have to have the same index, and they have to have the same radicand. That means the root needs to be the same. In this case, it's both to square root, so that's fine. And the radicand has to be the same. So this is a 5 and a 20. So these are not the same. But before you can just say, oh, that means they can't subtract, they can't do anything. You have to be able to know if you can simplify. This 20 can be simplified. So before I can do anything, I have to simplify this 20. Now let's list, I like to use the tree method. Let's list some factors of 20. Well, I know 2 and 10 make 20. 2 is the end of the tree, so I'm going to keep going. We've got 2 and 5. So I'm looking for pairs, 2 numbers that have to be the same. Well, I have 2 2s, so I can pull out a 2. And since my 5 does not have a pair, it stays in the radical. And that means these 2 have the same radicand. They're both 5. So that means I can actually subtract these 2. So I'm going to rewrite everything, and instead of the square root of 20, I'm going to write 2 square root of 5. Let's see how that's going to look. So I have 3 square root of 5 minus 2 times, because I now have 2 2's on the outside, times 2 square root of 5. So I can multiply these 2. 3 square root of 5 times minus 4 square root of 5. And 3 minus 4 is negative 1 square root of 5. And remember, anytime we have a 1, it's the same thing as having nothing there, because it's already implied with this negative that there is a 1 there. So I can just leave that as negative square root of 5. And that would be your final answer. All right, keep going. 8. So we want to find the product. Product means multiplication. When you're multiplying, the only thing they need to have is the same index. In this case, they are both square roots, so that means we can move forward. 8 times 12. You can multiply the 2 insides, and in this case, it'll get us the square root of 96. Now, square root of 96 is not our final answer, because we can simplify the square root of 96. It is not a perfect square, so we can't do that, but we can use the tree method. So what 2 numbers multiplied get us to 96? Well, because 6 is an even number, I like to always just multiply by 2. I find it's a little bit easier. You can find something else. And then 8, again, is an even number, so I can divide by 2. 24. And again, 4 is an even number, so I can divide by 2 again. Now, again, if you know what numbers multiplied to get you 24, 48, 96 that are easier for you, use those. I'm just going to keep dividing by 2 since they keep ending in an even number. 2 and 6. Again, 6 is an even number, so we've got 2 and 3. And that is the end of my tree. So let's look for pairs. well, I need 2 because my index is 2. So I need 2 of a number. So I've got 2 2s here. That means I can pull them out. I've got 2 more 2s here. So I can pull those out. Remember, anytime you pull anything out, if it's more than one set, you got to multiply them. And I've got a 2 and a 3 left. Since those are both by themselves, I'm going to put them in the root. And I'm going to multiply them as well. 2 times 2 is 4. 2 times 3 is 6. So that means my final answer is 4 square root of 6. Pretty easy. All right. Number 9. Evaluate the expression 4 to the 1/4 power times 4 to the 1/4 power. So I'm going to first turn these into radicals because it's easier to multiply. When they are radicals, this is going to be the 4th root of 4 times the 4th root of 4. They have the same index, so that means I can multiply. 4 times 4 is 16, so I'm looking for the 4th root of 16. Basically, that means what number, same number 4 times, gets me to 16? Well, I'll just go with what I know. I know 1 times 1 times 1 times 1 is always going to give me 1, so that's a given. Let's start with our 2's. 2 times 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that means 2 4 times is going to give me 16. So that means my answer in this case is going to be 2. Pretty easy. Remember, exponents and radicals are opposites essentially. So this, if you're confused at what you're looking at here, you're looking at 2 to the 4th power is 16. That means that the 4th root of 16 is 2. It's just kind of like addition, subtraction, multiplication, division. They're interchangeable. That's all that is. All right, and then finally, number 10. So it's looking for which of the following is not equivalent. Keyword not. So we've got the square root of 90 divided by the square root of 10. I'm sorry. So we can start by putting this in one big square root since they're both divided by, since they're both in the same root value. So that means I can do the square root of 90 over 10. Oh, looks like that's an answer. So that means it works. It's equivalent. That means it is not what I'm looking for. Now let's do 90 divided by 10. Square root of 90 divided by 10 is 9. Well, square root of 9 is here as well. And we already know the square root of 9. Square root of 9 is 3. So I also know that is not an option. So my final answer is going to be C. Square root of 8. All right, and that's going to be it for today's video, the Module 7 test review.